In the heart of the Iraqi desert, a young Marine sniper named Steve Reichert found himself facing a challenge that would redefine modern marksmanship. The year was 2004, and the battlefield was a landscape of extremes. The wind, a sniper's constant adversary, was more unpredictable here than anywhere he had ever trained. It wasn't just a gentle breeze. It was a swirling, gusting force that could push a bullet off course by several feet over long distances. For a sniper, a miss wasn't just a failure. It could mean a compromised position, a lost opportunity, or worse, a life. Standard military doctrine for wind estimation was, to put it mildly, insufficient for these conditions. Snipers were taught methods that had been around for decades, like observing mirage, feeling the wind on their face, or watching how dust and vegetation moved. These techniques worked, but they were more art than science, relying heavily on instinct and experience. In the vast open desert, where mirage shimmered like water and the wind came from multiple directions at once, these methods often fell short. A shot that was perfect in theory could be sent wild by a sudden, unseen gust hundreds of yards downrange. Reichert, serving with the 3rd Battalion, 5th Marines, was not one to accept the status quo. He was a thinker, a problem solver. He knew there had to be a better way, a more scientific approach to taming the wind. He spent his downtime not just cleaning his rifle, but observing. He watched the heat waves dance across the sand. He studied the way smoke from a distant fire would drift and curl. He noticed that the mirage, that shimmering distortion caused by heat rising from the ground, wasn't just a nuisance that obscured the target. It was data. The common wisdom was that mirage flowed in the same direction as the wind. If the mirage boiled straight up, there was no wind. If it drifted to the right, the wind was blowing from left to right. But Reichert saw something more. He realized the mirage wasn't just moving with the wind. Its speed and angle were directly related to the wind's velocity. He started to wonder if he could quantify this relationship. Could he turn this visual cue into a hard number, a precise wind call that could be plugged into his ballistic calculations? This was the beginning of what would become known as the Reichert wind formula, though he would later call it the mirage method. He started experimenting. During lulls in the fighting, he would set up his spotting scope and his Kestrel wind meter, a handheld device that gave an accurate wind speed reading at his position. He'd look through his high-powered scope at a distant object and observe the mirage. He'd carefully note the angle of the shimmering waves relative to the vertical crosshair of his reticle. Then, he'd compare that angle to the reading on his Kestrel. Over and over again, he repeated this process. He documented his findings meticulously in a small, weathered notebook. He was collecting data points, building a correlation between the visual angle of the mirage and the actual wind speed. Slowly, a pattern began to emerge. He found that if the mirage appeared to be flowing at a specific angle, say 45 degrees, it consistently corresponded to a certain wind speed. A steeper angle meant a stronger wind, a shallower angle, a weaker one. He wasn't just guessing. He was developing a system. He broke down the visual field in his scope into a simple clock face. A mirage boiling straight up was 12 o'clock 0 wind. A mirage flowing straight to the right was 3 o'clock, which he learned to associate with a very strong full-value wind. He began to assign wind speed values to different hour marks on this imaginary clock. For example, a mirage flowing at a 1 o'clock angle might equate to a 2 or 3 mile power wind. A 2 o'clock angle might be a 5 or 6 mile power wind. This was a breakthrough. It transformed a subjective observation into an objective measurement. A sniper no longer had to just feel the wind. They could now read it with a degree of accuracy never before possible, especially for the wind downrange near the target, which was often the most critical and hardest to judge. The wind at the sniper's position could be 5 miles per hour, but a kilometer away it could be 12 miles per hour and coming from a slightly different direction. The mirage method allowed a sniper to see that difference, but a theory is useless without proof. Reichert's chance to validate his new method came during the intense urban combat of the Second Battle of Fallujah. The city was a sniper's nightmare. The wind swirled unpredictably between buildings, creating complex vortexes and updrafts. Traditional wind-reading methods were all but useless. It was in this chaotic environment that Reichert's system shone. One famous account details a shot that cemented his legend. From a rooftop position, Reichert and his team spotted 3 enemy insurgents on another rooftop over 1,600 meters away, nearly a mile. At that extreme range, even the slightest miscalculation in windage would result in a miss of dozens of feet. His spotter, using conventional methods, was struggling to get a confident wind call. The flags they could see were showing wind from different directions. Reichert, however, trusted his new system. He focused his scope, ignoring the chaotic signals from flags and dust. He read the mirage. It was subtle, but it was there, a consistent flow, telling him the true story of the wind downrange. He calculated the angle, converted it to a wind speed, and dialed the correction into his M8 to a 1.50 caliber rifle. He squeezed the trigger. The massive round traveled for over 2 seconds before finding its mark. The shot was a success. He then made 2 more successful follow-up shots on the other targets. A 1-mile shot is a feat for any sniper. To do it 3 times consecutively in a combat zone was unheard of. It was a stunning demonstration of his method's effectiveness. Word of Reichert's success and his innovative technique spread like wildfire through the sniper community. When he returned from his deployment, he was asked to share his findings. He began formally teaching his Mirage method to other Marine Corps snipers. He simplified the complex physics into easy-to-understand, practical rules that a soldier could use under the immense pressure of combat. His once personal notebook scribblings were refined into a formal system of instruction. The Reichert wind formula, or the Mirage method, revolutionized long-range shooting. It provided a reliable, data-driven way to read the most elusive variable in ballistics. It gave snipers a significant advantage, allowing them to make accurate shots at distances that were previously considered impossible. This wasn't just an improvement, it was a paradigm shift. Today, reading the Mirage is a fundamental skill taught to military and civilian long-range shooters around the world. It's a standard part of the curriculum at elite sniper schools. The knowledge that Steve Reichert painstakingly developed in the deserts of Iraq has undoubtedly saved lives by enabling friendly forces to engage threats from a safer distance and with greater precision. His story is a powerful testament to the ingenuity and adaptability of the individual soldier. It shows how one person, faced with a life-or-death problem, can innovate a solution that changes an entire field. Steve Reichert wasn't a scientist in a lab. He was a warrior on the front lines who used observation, critical thinking, and relentless testing to solve a problem that had plagued marksmen for centuries. He saw the Mirage not as an obstacle, but as an answer, and in doing so, he gave his fellow snipers a tool to see the unseen and conquer the wind. Thanks for watching, and if you enjoyed this story of military innovation, make sure to like, subscribe, and hit the notification bell for more. In early November 2004, Mitchell is summoned to a room he did not expect to enter. The Scout Sniper School commandant, civilian contractors, and the very ballistics expert who publicly declared real-time wind measurement impossible. This is either validation or the end of his career. The terms are clear. One demonstration. If it fails, consequences follow. The wind that day is violent and unstable, perfect conditions for failure. Mitchell fires a ranging shot. The camera captures the vapor trail. Software tracks curvature. Calculations appear. He walks to the weather station. The numbers align within 2%. He repeats it 10 times. Silence fills the range. Skepticism gives way to disbelief. What Mitchell has done is not prediction. It is measurement. Real-time observation of wind's effect on the bullet itself. Formal testing begins. At Quantico, engineers refine the system. High-speed cameras, automated tracking, ballistic integration. What began as duct tape becomes military hardware. By April 2005, 12 Marine snipers test the system under every wind condition imaginable. Traditional methods achieve 34% first-round hits. Mitchell's system exceeds 70%. At 1,000 yards, the gap widens even further. The conclusion is unavoidable. Wind reading has shifted from intuition to observation. Deployment follows within months. In Fallujah, snipers fire single-ranging shots into safe backstops. The system calculates drift. Aim adjusts automatically. One shot, one kill. Enemy fighters notice immediately. Intercepted communications reveal fear. Movement during daylight drops. Positions are abandoned without contact. The psychological effect is as powerful as the physical one. Within months, sniper fatalities drop to 0 among teams using the system. Lives are saved not by better bullets, but by better understanding. Mitchell receives promotion, recognition, offers from defense contractors. He declines them all. He leaves the Marine Corps quietly and returns home to Tennessee, running an HVAC business. When asked years later about his invention, he shrugs. He says he did not invent anything. He simply paid attention when something did not make sense. His original notebook remains hidden in a drawer. The Marine Corps later publishes the case study. The conclusion is simple. Innovation does not always come from laboratories. Sometimes it comes from frustration, obsession, and refusal to accept that impossible is permanent. Before this story ends, consider this. How many solutions are ignored because they come from the wrong rank? And how many lives depend on someone refusing to stop asking why? If you value stories like this, support the channel by liking the video and subscribing. It helps keep these untold histories alive.